Leave the education, leave the philosophy, leave the future. The fact that I was getting paid 5,000 rupees back then, it was used money for me. I did try IIT JEE in 2011 and I missed by 1 marks. I had started to believe that, there must be something different for me.
Yes.
It's completely fine to not know what you want to do.
Hello, guys. Welcome to another intriguing podcast by TechoVedas. Today, we have with us our own founder, Mr. Kumar Priyadarshi, who shares his journey right from ISER to NUS to IIT Bombay and then on when he created India's first tech media company, TechoVedas, for sharing semiconductor insights with the world. So, let's get right into it. We'll discuss a lot of things related to semiconductors, entrepreneurship, and whatnot. Kumar Priyadarshi sir is a graduate from National University of Singapore. Then on, he went on to work for Global Foundries and A-Star, and then his calling came, and he came back to India and served as a research scientist at IIT Bombay. And after his power-packed and dense experience in the semiconductor market, he went on to start something new. The change can be brought not in the system but from outside. Those concepts we'll explore, and he is currently the founder of TechoVedas, the India's first tech media company for providing semiconductor insights. Starting off, sir, we would like to discuss about your journey. First, you started as a graduate and dual degree from ISER Pune, right, sir? Let's start from there.
Yes. Okay, let's go step back.
Okay.
So this is an interesting story because I did try IIT JEE in 2011 and I missed by 1 marks. And I thought that how is it possible that I'll not able to crack a simple exam? It was not simple at all. So I decided to prepare for another year, and in that year I qualified IIT. But as luck would have it, by that time I had decided that I didn't want to become an engineer.
Okay.
Sorry for a lot of engineers who are there. The story gets interesting as we go ahead from here. So I didn't want to become an engineer because everyone around me was becoming one, and I had started to believe that there must be something different for me. So this is where I came to know about ISER Pune. I mean, in general, ISER, there were 5 ISERs back then. I think now there are I
Yes.
think more than 10 or something. The most important part for me to join ISER was the fact that I was getting paid 5,000 rupees as scholarship. Okay. Leave the education, leave the philosophy, leave the future. The fact that I was getting paid 5,000 rupees back then, it was used money for me. That was the first thing that made me say, okay, leave IITs and let's go to ISER.
Okay.
So I went to ISER in 2012. I was there for 4 years. ISER's curriculum is very different from the engineering curriculum that you have. Mostly it's about reading physics, chemistry, math, biology. Didn't get interest in any of these. And by the time my 4th year ended, I was not sure what did I want to do. And this is important for all of you. Most of you are in your final years.
Yes.
It's completely fine to not know what you want to do. Okay.
Yeah. Just a
And
bit.
not to say that you'll figure out.
We have domains from all years, first years and second years, third years also. And just to, if I'm not wrong, your degree was in ISER was a dual degree, right, sir?
Yes,
In
it was a
which
5 year
field?
degree. So ICER's back, I don't know what is doing ICER doing right now, but back then ICER had an interesting experimental degree that they wouldn't provide a degree in any specialization. They would say
Okay.
that you are BSMS degree, BSMS dual degree. So if you ask them, am I a physics major? They would say no. You go and figure out based on the number of courses you have taken in a certain subject. So back then ICER wanted to do very radical things. One of the radical things was putting boys and girls in the same hostel. I mean, in the same building. So
Co-ed.
to a lot of you, I think this was the first time it was done in India. I don't know if that happened now, but back in ISER in 2012, first 6 floors used to be for boys and the rest 3 for girls. And you can understand the kind of chaos that would happen. So in by the time I had finished 4th year, I had done a number of projects and stuff, and I didn't know anything about what did I want to do. And by the way, even now, I don't think I have a lot of clarity. It might look like that I have a lot of clarity, which is not true. Most of the people that you would meet, you would find that they are smart. If you talk to them, you would find that they are the dumbest people. Probably that's another way to look at smart people, that they don't find themselves smart. That's how I am qualifying myself smart. Maybe I'm not. I'm just thinking of myself one. So the way it happened is that I had done a 3 months sort of like internship at NUS in my third
Okay.
year, and the same person wanted me to come there for 1 year master's thesis. So
Okay.
the degree is from ICER, while I did my master's thesis from NUS,
What
and
is
that was
NES, sir?
one. NUS is National University of Singapore,
Okay. Okay. Great, sir.
the place you want to apply for your master's.
Yes, sir. Yes.
Yeah.
Just for the public,
So I think
because the students are here from first year, so yeah, it's a National University of Singapore. And sir, how did you get this internship opportunity?
very simple. The thing about life is that most of the things are very simple. You have to do that simple thing repetitively. So for my internship, I wrote 1,450 something mails just to
Oh
get
my
a
God.
few months internship. So I would sit in my class and I would send 50 mails. I'm sure I must have sent n number of mails with a professor saying Christopher Fisher, and his name would be something else on the mail because I just copied paste. So all those childhood things used to happen, but mostly it was around sending mails and showing them. And these are all later I realized these are all art. Writing a good mail, writing why you are so passionate, because in third year you are hardly useful, to be very honest.
Yeah,
So
sir.
for someone to invite you from India, why can't they get a local? Because once you are from India, you're going there, there's a lot of visa and there are a lot of other formalities that they have to do. So it's very complicated, but mostly what I did is that I must have sent. That's why if you ask me any country, I'm sure my memory has faded now. If you ask me any country, I can tell you 10 universities because I used to do this top 10 universities in France, top 10 universities in
Okay.
Croatia, and I would go and mail everyone from material science to electrical engineering to physics to chemistry
Oh my.
because I was roughly in the all those domains. So I went to ISA, so I went to NUS for my master's thesis, and that's when accidentally I discovered something interesting, discovered in the science sense. So I ended up making something called 2D materials. And back then, this was the most cutting edge research on 2D materials. And that was
Okay.
done by a master's.
Okay.
So that was huge. So I ended up publishing a very high impact factor paper. I don't know how many of you understand impact factors, but impact factor is one way to judge how good a paper is. And back then, my impact factor was 14. So that was used, and that happened accidentally.
Is
I
it
ended up publishing
related
a
to
first author paper.
citations, sir? Impact factor?
No,
Okay.
citation is after you have published the paper, how many people have said that they have referred this paper for something for
Yeah.
their research?
Yes.
Impact factor is basically adding all. So impact factor is basically Amazon rating 4.9, 4.8,
Oh, okay.
right? So when more people cite your paper, more people, then the magazine itself has a impact factor to say that this is an important. So for example, Nature and Science are two journals. If there is one paper, you end up publishing one paper in your PhD, you're going to get a big job, like you can get a US university professor. Or I would go and say that most of the professors in India, IITs and IITs, most of them have does not have a Nature paper or a science paper,
That's really sad.
right?
And on this, because we are engineers, usually people come here to get a job, which is quite ironic. If you have the right skills, job will eventually follow you. So I would like you to highlight the importance of writing research papers and conference papers. So it would be very helpful for BTech students here.
um, See, I mean, I find this question very philosophical: skill versus knowledge.
Okay.
See, as students, you should. I mean, one of the way I look at student life, and I find people who are a lot scared during their college, they just want to get up a job. I'll tell you one thing: you should try so many things, especially for people who are in first, second, third year, fourth year. I think you're a little late for that, but for you have life for that. But for the first 3 years, try as many number of things. Try dramatics, try mechanical engineering, even if you are electrical engineer, try computer science, try something else, right? And once you try it really hard, right, fall in love with it, try it number of times. So what will happen is that if you have fallen in love with a certain topic, certain subject, and you really try hard, the best that will happen, you would realize that you hate it. And that's a good thing, to realize that you
Yes.
hate something. That means that you have n minus one thing to figure out, right? Now you try something else and you hate that also. Then you have n minus 2. And then n is not infinite. N is hardly 5 or 10. So the more you are clear, you don't have this thing about, I don't know if you understand, a lot of monks, right? Once they become monk, all their life they want a family life because they never had a family life, right? That's why Bhagwan Buddha becomes important because he had a family life to realize that he doesn't want a family life.
Yeah.
Unlike a different case where you never had a family life. So in that sense, try corporate job, try academics, try startups, try building one. And then you realize that it's not my cup of tea. That's good. Rather keep on thinking this thing, I would have become Elon Musk. So in the same breath of conversation,
Yeah.
try to go into really intense research. Maybe you have your calling there, maybe you don't. But if you don't try, you will keep on thinking that had I gotten on this station, that would have been my journey. So I would rather say not just research papers, for that matter, anything, try.
Yes, sir. Getting you, sir. So, those were very valuable insights on exploring things and then finding your niche. I just recall a Thomas Edison's quote while he discovered the bulb. I have not found 1,000 ways in which I could fail. I found 999 ways which wouldn't work, and the one way which worked. So, thanks for those insights, sir. So, we'll circle back to your masters at master thesis at Singapore. You shifted to Singapore, and then I guess according to your profile, you joined A Star. So would you give a brief what is A Star and what was your job there?
So basically, India has these institutes called RRI, which is Raman Research Institute. There is something called HRI, which is Harishchand Research Institute in Kanpur. RRI is in Bangalore. There are TIFR. So these are basically research institutes. The difference between a research institute versus a university is that in university you have to teach as a professor. If you have one professor, he can't just do research. UGC or MHRD does not allow you to just do research. You have to research and you have to teach. While if you are somewhere like RRI or HRI, there is no teaching sort of like compulsion. You just have to do the research. A star is similar. So in A star, there are scientists where people don't have to like teach. So that would let them to focus entirely on the research part. So I didn't join A star. My master's thesis was basically a combination of NUS and A star, where at A star I would be doing the experiment. So I was building something called CVD, which is chemical vapor deposition.
Yeah.
So I was at that point of time back in 2016 when I was at A star, I was building the largest possible area of a two-dimensional materials. Graphene is one of them. You must have heard of graphene.
Yeah, sir.
I was building that, and my paper also came in that. So that was the one whole year where I would be doing the research at A-Star, and I would be getting the money from NUS, and NUS and A-Star work very collaboratively. So that happened in my fifth year. So this is where I think what I was telling you earlier. So when you are at ICER, you are basically born to do research. That's what your professors would tell you.
Yeah.
And remember my story about IIT. Since everyone was expecting me to become an engineer, I decided not to be one. So it's the same theory. Every professor was expecting me to go and do a PhD, and I had 6 PhD offers back then. From all continents of this world. And this is when I realized that fundamental research was not something I was enjoying. It was very nice. It was very fancy. It was very easy for me, thinking first principles and stuff. But the fact that it was not like doing something to real life things. So I was making something 2D, which was in my lab. It didn't have, and that's when the story of not doing engineering comes back into the picture.
Okay.
This is when Global Foundries. So I had an interview at Global Foundries. One of my friend referred me to Global Foundries, and it was like I think for a half an hour interview.
Guys, please mute yourself.
couple dance
We are sorry.
के लिए पूछने बोले
Yeah, sir. Please continue. Sorry for the disturbance.
Yeah. So I had decided by then that I didn't want to continue this, because I would have gotten a star position there. But I didn't want to do that. It had started to feel boring to me. So Global Foundries, it was an easy interview to get in, because once you say that you have done all these exotic things, people in corporate think that you are the smart one. And most of the interviews are about either you intimidate the interviewer or interviewer intimidate you. It's your call. I mean, I have been lucky or I have been fortunate enough in most of the interviews. I haven't intimidated people, and that's when I have got number of offers.
So just to be
So
sure, you joined
yeah,
Global Foundries after 1 year at A Star, right, sir?
yes,
Okay,
yes.
so what is Global Foundries? And just to be sure, you graduated with a MS from Material Physics. And then on how you entered the semiconductor industry, I guess the role of Global Foundries comes here.
So basically, Global Foundries is third largest foundry. Foundry is something which makes semiconductor chips. All the chips that you have in your phone. This is something that I used to tell people 2 years ago. I'm not sure this is true now. That whatever phone you had,
Yeah.
I must have worked on one of those chips. Like if it's a Chinese phone, if it's an Apple, if it's an Samsung, Global Foundries used to make chips from all sorts of places. We used to have an Apple camera module. We used to have Samsung modules. We used to have all these Chinese phones. We used to make them, right? So basically, all the chips that you have, right, we used to make them. And the process that happens for building a chip, which is
Yeah.
more than 300 steps, I used to be in charge of one of those steps called CMP. CMP stands for Chemical Mechanical Planarization. It's a sort of a different detour for a different conversation. What you asked about, how did I end up going for material physics?
Yes.
If you think about it, semiconductor is about devices, A, or if you are thinking about in terms of design, that is B. This third part where you have to make the chips is basically material science in its whole glory. You are supposed to qualify a certain, so silicon is a material, silicon dioxide is a material, you have HFO2, which is
Yes.
hafnium oxide, that's another material. So it's material science. If there are people who are from material science background, it's one of the most important profiles to get into semiconductor material science, for especially for process engineering, which is one of the most coveted field right now, because
Okay.
we are now hitting the end of Moore's law. Now people want to have new and new materials. If you have seen 3D packaging, that's another material thing. If you have seen 3D memories, that's another material thing.
Yeah.
So
3D
that
memories,
helped
I
me to
guess, are
get into Global
stacking,
Foundries.
yeah, stacking things one over the other so that they are compact and
So there is a
area.
lot of material
Yeah.
engineering happening there as well. I'm sure you have people from branches like material science
Yeah.
or
Yes.
material engineering or metallurgy. All of those are sort of like useful in semiconductors.
Okay, so you were into the back end part of the the fabrication of the chip. Once it's signed off from a fabless company in Global Foundries, you fabricated the designs.
Yes, yes, yes.
Okay, sir, getting you. So, how was your experience at Global, sir? And then, what was the transition? I guess we are going towards your calling. Uh,
No, as I said, it was all eliminating that thing that you don't like. So if you remember, I didn't like engineering, so I didn't do one. Then I decided that I wanted to do research. I tried it. I didn't like it. That's when I went to corporate. Right, Global Foundry is one of a corporate experience. Uh, See, I'm going to say something very counterintuitive here.
sure.
Um, these foundries are great place if you are doing R&D there, right? Because someone who has done like new and new things all their lives, if you are asked to do the typical thing what has been going on there for last 5 years, right? Slight fine tuning, blah blah blah. It's not something that would excite a lot of people beyond the salary, because the salary would be exotic. Once you are in Singapore, then you are making in dollars. Then I am talking about, I would go and say twice the salary of IIT Bombay average graduate. That would
Oh,
be the minimum salary you would get in that job, right? So 1 year into the job, I had started to realize that again that it's not something that I wanted to do for a long time.
oh,
Uh, and it is around that time when I was starting to look for more and more interesting sort of places. This is when IIT Bombay and Ministry of Electronics were looking for people who would want to come back to India, who would be insane enough to come back to India, leaving that kind of a job. And I fit the bill. And I came back to India. When I came back, it was a 2% team. Since the point that I came back to the point that I left IIT Bombay earlier this year, I made a 15 people team. We ended up making the first memory chip of this country. We got minister's medal. We published here and there, and that's how the journey has been.
so we'll go into detail of this right now. Just to be sure, at what position did you join IT Bombay? At what capacity?
Uh, I had joined in something called senior research scientist. So this would be again, as I was talking about A star, right? It would
Yes.
not be a teaching thing. So and it would not be like you don't. So in the context of IIT Bombay, normally people would think of senior research scientists as people who would be doing the research. But I hadn't come here to do the research. I had started to realize that I wanted to build products 0 to 1. And I at IIT Bombay, most of the role was revolving around taking an idea and the products which have been built outside India already. Let's try to make that in this country. So, for example, the OTP memory that we ended up making was something that was made like 10 plus years ago
Okay.
outside.
Okay.
But in these technologies, the game is not about innovation. It's not that much of innovation. It's about having the engineering capability to build it.
Okay. So just to be sure, what
So
is
that's yeah.
OTP here for the public?
Okay. So OTP is one-time programmable memory. So basically, one-time programmable memory is something. So for example, if you do a banking transaction, right, you get this OTPs, right?
Yeah.
So OTP is called one-time password there,
Yeah.
right? So if you think about it, how would that work? Is that that particular number is basically decrypting a message at the banking end and now making your banking transaction smoother, right? If you don't provide that number or if you sort of like screw up with that number, you won't be able to do the transaction,
Okay.
right?
Mhm.
So basically, what is a OTP is that in your memory, if I don't know how many people understand how the memory works, but OTP is basically about when you are using memories like if in your phone, in your laptop, you are basically storing memory and erasing it. So if you have a
Yeah.
500 GB laptop, right, you're putting a video, you are removing it.
Yeah.
OTP is not that. OTP is basically you can only store once and you can't erase it. So, for example, if you think about the suitcase that we used to have back in those days when you could do 0, 1, 2 as the key,
Mhm.
and
Yeah.
each time you have to match that. So basically, that's one form of not electronic OTP, but that's one form of how OTP would work. That you would store a data
Yeah.
in a certain sequence, and then if you want to open that data, you have to match that sequence,
Yes, sir.
right? So that's how the OTP memory works. The beauty is that you can use this for all sorts of communication encryption. So for example, a lot of the communication that happens in India goes to China because we are all using Chinese phones, right?
Yes, sir.
Now if you want to have a WhatsApp in India, then that's an American company, right? The encryption is also American. So what the focus was back in those days, a lot of army people would come to us and ask us this, that can we have a, so they had built something of a WhatsApp in army. This is like 2 years ago, and they wanted someone to do the encryption of that, and OTP would be able to do the memory that we had,
Yes.
right?
Yeah.
So that is how the OTP memory sort of like took shape. And this is when we realized that this is something that can go bigger. So we ended up making a product and blah blah blah. That happened.
And so you developed this under Udayan Ganguly and teams, and you were the team lead there. So what was the feeling about after post the making the memory technology, the first India's indigenous memory technology? So how it went on?
Uh, See, this is interesting because if you think about how India's academia, right, does not is great at research is what I would say. The research which does not need a lot of infrastructure, it's doing decent. But this idea of taking a research and making a product, this is a completely different ballgame. You need really different sort of people who know marketing, people who understand business, people
Yes.
who understand how to take customers. And if you think about a company like Global Foundries on an Apple, how do they do? They have a marketing wing. They have a people who do product, right? But in universities, when you have most of the things taken care by people like professors, people like us who are not from the world of business, it gets complicated. And I would go and say that that is one of the reason why something like a DARPA in US works great. What DARPA is, you should all
Okay.
check it out. DARPA is one of the most critical organizations that has enabled translation from research to products. So most of the semiconductor thing that you must have seen used to happen at Bell Research. So, for example, I'll give you a very contextual example: OpenAI, right?
Yeah.
Now, at OpenAI, people do research. They don't make products. The whole saga of Sam Altman is that this guy now wants to do business and they want to do research, right? So
Mhm.
you need very smart people for a research to sort of like convert into a product. And I
Yes.
would go and say the similar feeling for IIT Bombay, that we were not able to make that research into a very viable product. Also, one of the reasons why I wanted to move on is
Okay.
because I had started to realize that once you are in such a big system, you are in IIT Bombay, which has 1,000 crore funding, then there is a certain kind of research and certain kind of inertia that will kick in, because there is no one like eating your job because you're not building product, because professors are supposed to do research. I would have lived there for another 10 years without any, because IIT gets a lot of funding. But I had
Mhm.
started to realize that I wanted to like do more crazy things, as you must have seen by now in my journey. So that's when I moved on. Yeah.
On this thing, so you covered that there needs to be a balance between research and then converting that research into something useful, making a product. So we need to balance the academics and the economic aspects of this, if I'm not wrong.
No, I'm not saying that. I am
Okay.
saying universities should do research, and then it should be taken up by a different body, that this is your research, we are buying your patent, and now we will make a product out of it. We will find customers for it, we will find people who will pay for it. Not universities. Professors have done PhD in electrical engineering, PhD in this and PhD in that. How are they supposed to build products? It's very tough, is what I would say. There are some professors who have done it like, well, and but I would say this is not their cup of tea.
Okay, getting you, sir. Sir, while your 4 year experience at IIT Bombay, you covered a lot of administrative experience there. You developed a memory, and also you were involved in ISM. ISM, by the way, guys, is the Indian Semiconductor Mission. It is a nodal agency for improving the semiconductor market in India and bringing investors to have plants, semiconductor manufacturing plants in India. So, sir, you were involved in that mission, and what was your role there and how you got into it? And also, can you please highlight how a BTech student like we us can contribute to the mission?
So I think around the time COVID happened, the China started to put in a lot of chains on the supply chain, right?
Yeah.
And government started to realize that we need to, and that is where the whole ISM and everything has started. It's around April 2020 is when the government started to believe that we should do something, and whatever it was called, that we have to make semiconductor fabrication in India. There was a semiconductor lab in Chandigarh which was going at its speed. So
Yeah.
at that point of time, government started to entertain an idea which was proposed by Udyan at IIT Bombay,
Okay.
that let's make an R&D center for India. Okay, what was an R&D center? Was basically what I was telling you about, that universities should do research and there should be an institution which would take that research and build a product out of it. And it was a very extensive 200-page report. I was one of the 8 coordinators of that report, right?
Report of India
And
Semiconductor Mission.
so it was a report which was about India's R&D center, which was under India Semiconductor Mission,
Okay. Okay. Got it.
right? Which is now that you see ISRC, which is now the recent report that you were talking about a few
India
days ago,
AI
right?
report.
So that yeah. So that report, the genesis of that report is that 200-page report that was written in during the COVID years of 2020 and 2021. So what we did is that we sort of like evaluated the equipment cost. We evaluated if we want to take a process transfer from an IBM or a iMac, how would it cost? I
Okay.
was in charge of talking to all the R&D institutes of the world. So like ITRI, which is in Taiwan, A-Star, which is in Singapore, iMac,
Yeah.
which is in Belgium. There is a Tyndall in Ireland. So there were like 8 institutes. So I was in charge of that, as well as I was also sort of like co in charge of how to find what would be the budget of building a fab in India, what would be the process, what would be the clearances, and this and that. So that was a report we eventually submitted to ISM, and
Okay.
it took a while. I think the whole system is to a certain speed,
Yeah.
and with that speed, things are moving on. And I think there are not lot of things that should come out of ISM, But since India in last 30 years have tried to do semiconductor for a number of times, this time it seems the most emphatic. But elections are coming up, so there are a number of sort of like things that could go wrong, and I hope that none of them go wrong. And this time we sort of like get a good fab. And what I've heard is that we are going to get number of fabs, even if it's not silicon fab. I'm okay if we have power semiconductors, if we have memory fabs. We have already have a packaging fab now of Micron in Gujarat, right?
Yeah,
If
yeah.
we get more number of this, as long as the noise is there, that should work. To answer the other part of question, how do you get part? I wouldn't advise any of you to take part in ISM now. Okay,
No.
what ISM wants is people who have gained skills at the payroll of applied materials, at the payroll of Micron, at the payroll of Synopsys, to come and help government build this ecosystem. Right now, you don't have that. So even if you take part in that, you won't be that useful,
Yeah, getting you, sir.
right? So first I would tell you to gain a lot of experience, be it India, abroad, doing a PhD, doing a master's, whatever. But first gain a lot of experience before you think about contributing to such a mission, is what my suggestion would be.
Okay, getting you, sir. So this was your experience for ISM. You had a report, you remain contributor there, and enablers. But then on, you went on to create your own venture, which is TechoVedas, if I'm not wrong. Yeah, it's one of the India's first tech media company. It shares insights about semiconductor news in your blog, sir. So how did you thought of it? How did you trace the path?
So see, I have been very lucky in going to very good schools all my life. So I went to ISER, then I went to NUS, then I came to IIT Bombay. So I had never seen people who who don't have a certain infrastructure or a facility. And when you are into these colleges, you also get this sort of like idea of doing it at any cost. Like most of the people in these institutions won't ask for what is it that's missing, and they would try one way or the other, like get it done kind of attitude, right?
Okay.
But when I came back to India at IIT Bombay, and I was doing a lot of research of how students are doing this, and I started to realize that there's a lot of facility that is missing in India, right?
Oh.
And facility is something that I don't think I could have done much about. But the other part of it is that there is a lot of knowledge that is out there, right? Students don't have the vision or the capability or the clarity or the direction to look at them, right? And I started to see that there were a lot of coaching institutes who would charge you money and that, this and that. And this is where I didn't want to do that. So I didn't want to start anything for money. So if you have seen Social Network, right? Mark
Hmm.
says to his co-founder that I don't think I would do it for money, and eventually money would come, right? So I don't think one of the very core philosophy of TechoVedas is not to get rich. Okay, that is one thing, that I don't want to get rich through
That,
this.
yeah.
Okay, I'll survive on other means, right?
Yeah, the goal is to
So
create
that's
an
one.
impact, sir. So just to be sure, the you coachings you talked about, if I'm not wrong, those were VLSI coachings, right? Which provide training
Yes,
after engineering, right, sir?
yes. So I don't know, I have never had personal interactions with any of these coachings, but what I have seen is that in general there is a lot of this mentality of telling students that you don't have this particular skill, you come to our coaching, you charge this much and we'll get you a job. I think philosophically it's wrong. You should never promise anyone to get a job, because the best you can do is teach someone skill. You can't get anyone a job. I think that's very shortcutish kind of thing. I don't agree with that. But more than that, this idea of students not being excited and doing it just to get a job was a bigger pillar of which ended up becoming a philosophy for TechoVedas. That once you know that in, say, for example, in China, I don't know how many people have read TechoVedas, but if you read, like, I would advise all of you to just in the next 1 week, every day, just go to TechoVedas for 15 minutes, right? And just see what's happening. Even if you don't understand much of it, that's not a problem. China is making an AI which is 3,000 times more faster than NVIDIA's, right?
Mhm.
France is working on something very high end. Singapore is working on something high end. India is also working on something very high end, right? The question is that I want students to be excited about, okay, this country, only when you start having these kind of conversations in your head, that
Yeah.
can we make a neuromorphic chip? Can we make a memory chip? And I'm sure, I don't know how many of you know, but most of the fabrication nowadays has become almost free, with a number of foundries, with a number of Google programs, with a number of Skywater programs. You just have to come up with an idea, work on it, get a chip. And I'm telling
Mm.
you, as a student of even a PhD, if you have one chip which you can say that this does one thing little different, even with a 10% betterness, you are the best sort of like undergrad of all your batch, or rather I would say in India, because none of the undergrads that I know of have a chip. Most of them are trying to get a 9 GPA. But why to take a race which is very tough? Rather try, use something else, use your brain, and try to build a chip outside of your curriculum. Talk to your professors that, sir, I think this is the design. There is a RISC-V already out there. Why don't you design a microprocessor
Yeah.
using a RISC-V? Free. You just have to learn in 3 months. And maybe in 6 months' time, you will have a chip. You go to Intel. In your interview, you tell them that I have a tape out on my name. I don't think the interview will happen. You will be hired that at that moment.
Okay.
So that's also one of the ways I have lived life, that I have not changed like most conventional thing, because A, I don't think I am qualified enough to do that hard of a person, that hard of a job. And B, I have realized that I can do much better things in more unconventional ways. So that's what TechoVedas is about. It's about exciting people. It's about telling them what's going on. It's about telling them how can they do that. It's about giving them quizzes on various fields. It's about, in general, making them aware about an industry that they are doing a job for, or they want to do a job for.
Okay.
Because if you're not excited about it, then I don't see something new coming up. And if you're not trying to do something new, then basically you are one of the many. And that competition is fierce. So I'm basically giving you a shortcut to becoming, like, have a lesser competition if you just do things a little bit different. So that would be the vision of TechoVedas. Yeah.
Okay. So that was a really great insight, sir. Just guys, tape out the word he mentioned here is actually the end design, which will send to the fabrication unit. Yeah, we have this chip, or you have this chip fabricated. So if you have that, it will be a very nice project or product for your startup, for your interviews. So and all. The thing is, you need to have good projects. And just we are left with 15 more valuable minutes. We would like to help people here to join the VLSI industry. Most students are of second year here. We have must have some PhD students also. Who knows? We have people from different backgrounds, but they are all are new. Things are happening in our college. Suppose this meeting itself is serving to the cause of having people into the semiconductor and VLSI industry. We have C2S project in our college, in which ISRO, I guess, has given us the part of making a power management IC. So we are all grateful for that. But just for the sake, most people are not exposed to this thing. So what would your advice be for students to and how can they enter? Is a master's necessary, as Intel and Nvidia hire MTech graduates more? Qualcomm, MediaTek, they come for MTech here, but they don't come for BTech. So would we should we do masters? If yes, can you highlight some good universities, or a direct job if we get would be a great thing.
See, I am of a contrary belief. I don't believe in a lot of education. I feel that education is a lot of fluff on the name of building skills. If you want to build skills, right? How do you build skills? Do projects. How do you do projects? You go to professor, talk to them that even if I'm a bachelor, I am ready to put in time and I want to do this project. Even after your, maybe after your bachelor's, give 6 months to that project, and by the time you are done with that project, you would know as much as a master's would do. Because even if I'm talking about IIT Bombay masters, only in their third year of masters they do extensive research. First 2 years are again about courses. So it's sort of like a combination of what you want versus what is out there. I'm sure what you said is right. That a lot of companies wouldn't want to hire bachelors, and the reason is because the precedent is set in a manner that bachelors people don't have any extensive understanding, deeper understanding of
Yeah,
any device and physics, blah blah blah.
yeah.
But that depends on you. Can you, do you want to do a three? Do you want to invest 3 years, or do you want to do it? If you want to do it, you don't need to do any degree after your bachelor's. You try to figure out. You take part in this conversation. For example, in the TechoVedas community, right? We have a TechoVedas community where people ask, what should they do, right? And there are other people who would sort of like answer to that. So I'm not saying take away that you take part in other forums where people are discussing VLSI, right? And you
Yeah.
start, once your brain starts to, like, for example, an Instagram, right? You have this idea of switching on Instagram every 15 minutes, right? That's basically a habit formation.
Yeah.
If you want to become a VLSI engineer, or if you want to become good VLSI engineer, you have to start thinking about it, right?
Yes.
Can I do a course? Can I buy a book? Can I talk to someone? Can I work in a service company for 1 year and get like very good understanding and then jump to a product company? Can I get an internship in a product company? You have to start using your brain. You don't, if an Nvidia is not coming to hire bachelors, there are multiple other ways to reach Nvidia, right?
Yes, sir.
You have to show that you are good enough. Then people, I'm telling you, most of the companies, if you are sitting with the right set of people, if you have shown initiative, I have hired a number of people, and the only thing that I would hire for is the initiative, and
Hmm.
not the fact that how much degree you have, how many sort of like courses you have done. Have you shown initiative? Because eventually the job is about people who don't take initiatives, and they are being carried by people who take initiatives.
Okay. Initiatives here means doing
So wait,
something first hand.
yeah, in general, taking this, even if you are a part of a company, right, and you have gotten a job, say in Nvidia, you have gotten a job, understand what is it that Nvidia, your particular department, is working on, and I'm sure you can do some research and come back to your manager. Sir, I am only 3 months into the job, but I think this is one way. ARM did it. This is another way. AMD did it. Can we try this? And most
Hmm.
probably you would be asked to screw off, right? But that's not. But you would still be a very important person to ask questions, that this is a guy who has put an initiative beyond his job requirements, right?
Okay.
Even in your college, try to become that person who is putting extra hours, putting extra effort, extra brain, extra ideas. And how do you get that? Find people who are smarter than you, talk to them, be with them, ask a number of questions, talk people on
Yes.
LinkedIn, find more interesting people, and that's how you learn things. Yeah.
Yeah. So I
I've
guess.
never learned anything from a teacher. I would go and say very strongly, most of the things that I've learned in life, by failing, by Google, YouTube, all those things. That's why whenever Happy Teachers Day, I say Happy Teachers Day Google.
That's great insight, sir. We have definitely learned a lot from Google, the most of the BTech students here. And guys, I guess for discussion, TechoVedas is the best community out there in there. We need to work hard to surpass China or be at least in at par with China in soon. And this Indian semiconductor mission, startups like TechoVedas, startups like Sign of Semiconductors, and an n number of startups that are Indian startups that are in the industry are all promoting the research and product development in the semiconductor industry. The field is open to all, and you all can explore. There's a thing that people are like to be on the receiving side of things. So I'll ask a question from their side to you, sir. So what are the subjects we should focus on? What are the BTech second year students should think of to go into the semiconductor industry?
I am not sure about the courses, but I'll tell you what are the skills that are required, and you can think about the courses that can take you that skill. So first is that very basic, understand the digital design, right? The first thing you should learn is digital design, the logics of it, how does it work. If you have Cadence, Synopsys, then you make use of that.
Yeah.
If you don't, then try to use open source softwares for that, right? Then once you have some understanding of digital design, there are multiple depth you can take. And if you realize that digital design is not your thing, try analog. Again, do the same exercise. If analog is your thing, then you have two skills. If not, then do mixed, right? These are all like very generic thing, but try to build at least skill in one of the three. That's the basic thing that is required. If you don't have any skill in any of this, then that itself is a sort of like a place where you won't be the most sought person to get a job, right?
Mm.
If you want to talk about device, right, the very basic device physics is something that you should understand. Very basic. How does a
Yeah.
transistor work? How does a memory work? How does a processor work? Very simple things, not like very complicated. Most of the things that we hear in our life is very complicated, right?
Mm.
So we have to make sure that the more you simplify things, Beyond this, if you want to do process engineering, then the first thing that you have to understand is the process flow from a point that you have wafer to the point that you end up making a transistor. What happens in between that? So you start with a deposition, then you do some etch, then you do some more deposition, then you do some CMP, then you do backend engineering. You have to understand the flow. So if you just do a physics of semiconductor devices, if you understand that book itself is enough for process engineering. If you want to do system engineering, again, basics of system engineering is a course on Coursera that you should do. I don't know if you have courses on basics of system engineering. System engineering is something that is very, very important as we go ahead, because most of the work
System
on process
design,
has
right,
been
sir?
done. Yes,
Okay.
most of the work on design has been saturated, but system is something that more and more new systems are coming
Okay.
up.
Okay.
So there are a lot of jobs there.
Got it,
So
sir.
that's about
Yeah.
it, is what I would say.
Yeah, sir. So just an overarching conclusion, focus on digital electronics, analog electronics, mixed signal IC, their semiconductor fabrication the VLSI design flow, right from RTL coding, registered Verilog coding to the mask layout, and then to the fabrication. So all those resources are available online. We'll share your resources. As we are running short on time, we'd like to conclude this session, and I would like to really thank Mr. Priyadarshi sir to give your valuable time to us, and you have given a lot of exposure to students here. So a big gratitude wave going towards you, sir. Thank you so much.